So, BBC News, yes, they've got weird left-leaning biases, but it's a report of something that happened. It's fine. So the first ever black hole image released. Now I've seen people calling it a photograph. It's not a photograph. It's an image. Photos are photons, but you get photons. Um, Photons are used in order to make an image. If you imagine that, I don't know, you want to take a picture of a car, and so what you do is you bounce paintballs off of a car, and each of the little paintballs is designed so that it explodes on the second bounce. So you bounce the paintballs off the car. When they come back off the car, they hit your canvas, and everywhere they hit a canvas, they colour a pixel. So it's bounce splat. That's basically how photographs work. Photons bounce off of your face, hit the sensor on the camera, and darken a pixel or colour a pixel or whatever. That's not what's happening here because it's so far away and you can't necessarily see it with regular light. When we're looking that far into the distance, into the past, however you want to look at it, we can't use light to observe, so they use radio telescopes. So you'll get images like this where they talk about, where does it say here? Where is it? False colour images. Yes, they've technically been doctored, but what that means is they're not using light to find the picture. Now, there's a thing called redshift, okay, the Doppler effect. All right, something's coming towards you. Let's say it's a race car. It comes towards you, and as it's coming towards you, that it gets higher pitch, going, and then as it goes past you, it goes lower pitch, going, yeah. The high pitch is as the sound waves in front of the car are being squished, squashed, what have you, and as it goes past you, they're being stretched. Okay. Same thing happens with light. So as something moving towards you, the light waves get more narrow, not narrow, they get squashed, whatever the term is, and as something's going away from you, it goes further apart. We refer to redshift because things in the universe are expanding, getting bigger, moving away from us. Every point in the universe is moving away from every other point. So the fact that we can tell that everything's moving apart because it's more moving away, redshift, means that we can tell the universe is expanding. But back to this. Visible light is on a spectrum, the electromagnetic spectrum, okay? And this shifting doesn't just happen up and down the visible light part. It goes all the way down to gamma and all the way up to radio waves. I believe they're at different ends. If they're not, doesn't matter. The point being, it can go anywhere on the spectrum, okay, to the far ends. And what they do when they're getting images like this one is they essentially are getting all of the different frequencies of radiation, radio waves, whatever it is the telescope is receiving, that data, and essentially they just turn all the levels down. Okay, and in turning all the levels down, so let's say for example this image was massively redshifted and the waves of light were spread out so far they're not visible light anymore, they've just turned into radio waves. Well, at that point, all they do is they digitally shrink it again. Yeah, they unredshift it, and that's when they get these images. It's not false color, as in it isn't. It's not photoshopped. It's not doctored in a sense. They're essentially returning the color that was previously there. I can't think of a bit like if you on CSI where they might get someone might talk through a like a voice disguising machine, and they might turn it backwards to figure out the person's voice, or if you could run an algorithm on Darth Vader to figure out what he was supposed to look like, sound like rather. So what they did is they got a bunch of radio telescopes. So we've got NOEMA, IRAM, Boston, LMT, APEX, ASTE, ALMA, SPT, AROSMT, SMA, JCMT, CSO, CARMA, LMNP. All these different radio telescopes all over the world, and they essentially used them as a giant radio telescope. They pointed them all at the sky at the same point. So they're not evenly spaced, but that doesn't matter too much. I did read that this was something like days worth of or hours worth of imagery. And again, not imagery technically, they're just getting the radio information from that point in the sky and then they're bringing it all back down together. Now, if you've ever tried to stitch together photos, stitching together photos is hard. Stitching together this stuff and bringing it back, and from different telescopes at different resolutions, it would be like trying to use the phone on, like the camera on an iPhone 7 Plus, and I don't know, one of every different variation of iPhone back to the 3G, and a webcam, and they're all weird distances apart, and you take photos of the same scene and then you try and stitch them back together to make a single picture. Very, very hard, and of course they needed a computer algorithm or computer algorithms or something. And this woman, now they keep referring to her as Katie Bowman and calling her an MIT student. She may have been, but she is currently a doctor, so she is Dr. Katie Bowman. She developed the algorithm that pieced together the data. This is all the data. There was something like multiple petabytes a day or something. Like the amount of data was insane. So scanned it over 10 days. 55 million years away, and they are looking at doing this with the black hole in the middle of our galaxy at some point as well. It's really, really interesting. Basically, they turned the Earth into a giant radio telescope. She's not the only one involved, obviously. There were hundreds and hundreds of people, probably thousands of people involved. But she developed the algorithm that created the image. Lots of people are going to say that a big deal is being made of her being a woman. It kind of is a big deal because previous female accomplishments in science haven't always been made as big a deal of as they possibly could have. But yeah, she's not the only person involved. They turned the planet into a radio telescope. Really cool stuff. Yeah, so they are working on... Oh, also, the fella who was in charge, or someone who was in charge of this, or involved in this, the idea that you get light going around a black hole like this, around the top, that's something that was seen in the movie Interstellar, and that was not just CGI art. That was a simulation based on the best hard science available. And it turned out that the man who's working on this, or had worked on this or something, also was the person who either wrote Interstellar or directed it or wrote something. Anyway, point being, if you look at Interstellar, it shows this stuff and it actually proves that they were correct, because this is essentially, for want of a better term, a photograph of what this actually looks like. And obviously they could attempt to make better, higher resolution images in the future as well. So yeah, very interesting, very cool stuff. We finally have... Just remember, until 1991 we had no actual proof of any planets existing outside of our solar system. We essentially knew they were there, but because why wouldn't there be? But we didn't have any proof. 1991 we found the first planet outside our solar system, and now we've got, I think, what, tens of thousands of Earth-like planets we know of, and now we've taken a photograph of a black hole. So science is moving quickly in lots of areas. Toodaloo.